Let us understand and practice how do we apply the power rule to find the derivative. These 6 examples will give you all the cases you need to know. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will understand how do we apply power rule to find the derivative of a function. Well, in calculus, this is the first rule which you learn for directly finding the derivative of a function. With the help of these 6 examples, we'll explore the rule. Basically, the general power rule is if the function f of x is x to the power of n, where n belongs to real numbers, then the derivative of this function will be n times x to the power of n minus 1. So in the derivative, the power is decreased by 1 and the function is multiplied by n. Well, there's another very interesting rule which adds up to it, which is a constant multiple rule. If I multiply a function by a constant, then the derivative will be constant times the derivative of the function. So when this is applied to the power rule, then power rule can be written as if f of x is k x to the power of n, in that case, the derivative will be n times k, so it gets multiplied by the constant x to the power of n minus 1. Is that clear to you? Perfect. So with that in mind, let us continue to solve these questions, rather find the derivative. Derivative means differentiate with respect to the unknown variable, which is x in this case, right? So the question here is find derivative using power rule, 6 examples, and as I said, derivative is differentiate with respect to x. So x is the independent variable. We'd also write this as dy dx. Is that okay? And prime notation f prime x for a function. Y prime also can be written, right? So all these are different ways of writing the derivative. Is that clear to you? Now this is the very first lesson on directly finding the derivatives after understanding limits and the first principle, correct? So you can always pause the video, answer these questions, and now let us look into how do we really find the derivative. So question number 1 here is y equals to 3x squared minus 2x plus 1. So you see now what I've done, instead of taking just one term, I have taken 3, right? So let's rewrite this. We have the question now as y equals to, the first term is 3x squared. Next is minus 2x. And then we have a constant 1. Now, if you apply the power rule combined with the constant multiple, I could find the derivative of this. And I can write here dy dx, differentiating with respect to x as 3 times 2, right? 3 times 2, x to the power of 2 minus 1, which is 1, minus 2. Because x to the power of 0 is 1, right? So if you write this, you'll say times 1 times x to the power of 0, which is 1, and the derivative of a constant is always 0, okay? So I could write this finally as 6x minus 2. So that is the derivative of this particular function. So we have applied the derivative rule. In addition, you will see we have added and subtracted each individual derivative. So that also goes with the 2 other rules, which are sum rule and the difference rule. The sum rule states that if both f and g are differentiable, then the sum of f and g derivative will be sum of the derivatives of each. You get the idea, right? So f plus g derivative is equals to derivative of f plus derivative of g. Now if it is difference, even then it works, right? So we have done a constant multiple, sum and difference in this particular example. Is this step clear to you, right? Now, let's look into the second question, which is y equals to square root of x. Now, we want to apply the rule, and let's rewrite the rule, which is if y equals to, let us say, x to the power of n, in that case, the derivative dy dx is basically n times x to the power of n minus 1. Now here, what is n? N is half, right? So let's rewrite this particular expression. So I could write this as x to the power of half, right? Now, the derivative dy dx will be the exponent, which is half, right, times x to the power of half minus 1. You get it? So that is half times x to the power of half minus 1 is minus half. Okay? Now, minus half means I have to write it in the denominator, right? So I get dy dx as equal to half times 1 over x to the power of half, which is same as 1 over 2 times 1 over square root of x, which I will finally write as 1 over 2 squared x. Is that clear to you? So these are the steps followed to get the result. Well, this is the very first time we are doing it. So I've explained you each and every bit of step which is involved. However, soon with practice, you should be going from this step to that step directly, right? Half to the power of x to the power of minus half, which means square root x will come in the denominator. Is that clear to you? Perfect. Now, in case you want to learn from me, you can always send an email on the address given. Most of my students are doing extremely well. They're right there on top of their class getting awards and scholarships like Akshay.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandilani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now, let's take up third example, which is y equals to 2x to the power of 5 minus x squared plus 1 over x. So the strategy here should be to simplify the expression. So we could write this as y equals to 2x to the power of 5 divided by x, right, minus x squared divided by x plus 1 over x. Now, 2x to the power of 5 divided by x is 2x to the power of 4. So we got this as a power function. You get the idea. And here we have minus x. And then we have plus 1 over x, which I'll write as x to the power of minus 1. Correct? So I've written each term in the form of y equals to a times x to the power of n. Do you see that? Now I can write down the derivative, which will be y prime a times n times x to the power of n minus 1. You get the idea. That is why I wrote it like this. So the strategy is clear to you. So we'll apply the extended power rule, which is with the constant multiple, right? And this is now the function for us, right? So let's write dy dx. So we get dy dx as equal to what? Dy dx is equal to, for 2 times x to the power of 4 will be 2 times 4 x cubed, right? And then minus x will be minus 1, x to the power of minus 1. So plus minus 1 times x to the power of minus 2, minus 1, minus 1, correct? So now we can combine the terms, simplify the expression. 2 times 4 is 8, so we get 8x cubed here, right? Minus 1, and that is minus 1 over x squared. Is that clear to you? Perfect. So that becomes the derivative of the given function, right? Next question here is y equals to 2x minus 3 whole square. Now here we have a function, then square. How do we apply the power rule? I need to write it in terms of a x to the power of n, each term, right? How do I do that? Well, in this particular case, let us expand it. You can expand using the formula a plus b whole square, right? A plus b whole square, as you know, is a square plus 2ab plus b square. Now, if it is minus, in that case what? Well, if it is a minus b, then this is minus. Standard formula known to you. So we can now write down the expression given to us as y equals to 2x minus 3 whole square as 2x a square, right? That is 2x whole square minus 2 times 2x times 3 times plus 3 square, right? So that gives you 4x square minus 6, 2 times 2, 4 times 3, 12, right? X plus 9. So that becomes our function. Now we can apply the extended power rule, right? So differentiating with respect to x, we get dy dx as equal to 4 times 2 times x minus 12, right? X to the power of 0 is 1, and therefore we can write this as 8x minus 12. Is that clear to you? Correct? So slowly we are cutting down on steps which can be cut very fast, right? Now, you could write this as derivative of the given function. So if you have something like this, you need to expand and then apply the power rule. We will soon learn how do we do this using a chain rule, right? So that is the next question. So that will be next. Is that okay? Perfect. So let's continue with our question set. Here is the next one, question number 5 for us. We have y equals to, let me rewrite this. We are given y as equal to 2 times fifth root of x cubed. You see that? So it is a good idea to write it in exponent form, 2 times x to the power of 3 by 5. Is that clear to you? Now we can write dy dx as equals to 2 times, that is a constant. Now the derivative of x to the power of 3 by 5 will be 3 by 5 x to the power of 3 by 5 minus 1, right? So that is 2 times 3 is 6, 6 over 5 x to the power of, taking common denominator, that is taking away 5 from 3, we get minus 2 by 5, correct? So this can be written as 6 by 5. With power always positive, we write our answers. So that goes in the denominator, 1 over x to the power of 2 by 5. So that becomes our answer, right? So many times you would also write this as dy dx as equal to 6 over 5, and this is fifth root of x square, right? So fifth root of x square. Makes sense? So that becomes your answer, right? So either way, you could have written your answer. Perfect. Let's move on and take the last question now. So in the last question, we have combined most of the things which we have learned. We have 1 plus square root x times 1 minus 1 over square root x. How will you do this? Well, you can pause the video, answer this particular question. We'll first expand and simplify, right? And then apply the power rule. So let's expand. So using distributive property, 1, when you multiply with 1, what do you get? We get this is equal to 1 minus 1 over square root x, correct? Now you multiply with square root x, and what do you get? We get square root x, and when you multiply square root x with 1 over square root x and a minus sign, you get minus 1. Is that clear to you? Perfect. And you could apply the formula a square minus b square also, right? It's kind of thing. Okay, not really. So anyway, when you do this, that is what you get. Now 1 minus 1 is 0. So you are left with minus 1 over square root x plus square root x, right? Okay. So now let us write this in exponent form and then find the derivative. So it becomes y equals to minus x to the power of minus half plus x to the power of half, correct? So now the derivative is what? Let's write down the derivative. dy dx is equal to minus, and then we have minus half times x to the power of minus half minus 1, right? Let me write minus half minus 1, correct? Plus half times x to the power of half minus 1, correct? So that is equal to, when you open this bracket, minus and minus becomes plus. We get half of x to the power of minus half minus 1 is minus 3 by 2. And here we get plus half of x to the power of minus half. Now it is important to write with positive exponents, and therefore we are going to write this as 1 over 2 x to the power of 3 by 2 plus 1 over 2 x to the power of half, which you can also write in radical form as 1 over 2 times 3 by 2 means square root of x cube, right? Square root of x cube, and plus 1 over 2 times square root of x. Is that clear to you? So that becomes the derivative for our function. So with that, we have done all the solutions, and now I hope you understand absolutely clearly how do we find derivative using power rule, which has been extended by a multiple with a constant, and also add and subtract rule. Perfect. So in the first case, we added and subtracted each derivative. In the second case was straightforward, but we learned how do we do derivatives with radicals. Here we simplified the expression. Here we expanded, right? And then applied these strategies in the next two questions to really perfect our skills. So I hope with this you have mastered the skill of using power rule to find the derivative. Thanks for your time. And in case you want to share your suggestions, you're most welcome. And if you want to learn from me, you can send an email on the given address. Thank you and all the best.